Hey folks, welcome to another episode of the Eclectic Engineer. This is your host, Jonathan Tuan Trong. And in today's episode, we will be going over the concept of AC and DC voltage, as well as LDOs, linear dropout regulators, and how the two of them interact with each other to be able to power devices such as your phone or your computer, your audio devices. First of all, some of the history of the AC and DC voltage is in the 1800s. There was a technological war between Nikola Tesla and Thomas Edison, two scientists, engineers, and physicists that vouched either for AC voltage, Nikola Tesla, or DC voltage, Thomas Edison. And if you've ever been curious about the mains voltage or the wall outlet voltage at home, you would know that it's connected to circuit breakers in the home, connected to the transmission lines, connected to the power grid, connected to either a nuclear plant or where it's powered by coal or through nuclear means, and various other technologies too, such as wind farms, hydro plants, and if you look at the waveform on the oscilloscope of a AC waveform, you'll see that the waveform is shaped like a sine wave or a cosine wave, very much like the way that if you've taken pre-calculus or trigonometry, there are sine waves, cosine waves, and tangent waveforms. Actually, the way that transmission lines work is because it carries AC waveforms. There is less power dissipated through heat and less energy is lost when traveling through longer distances through those wires. That's AC technology. If you think about a television at home or a computer, laptop computer, you'll notice that you have an AC adapter which transforms with a transformer which has a primary and secondary magnetic wire winding, which turns one AC waveform, converts it to magnetic energy in a magnetic field, and then either through a half bridge or full bridge rectifier is able to turn it into DC waveforms, which is direct current, which powers perhaps a 20-volt battery on your computer. Or switch on your television. Think of voltage, either AC or DC. If you look at a DC waveform through a oscilloscope or digital multimeter, you'll see that it is a consistent flat waveform, a line of the same slope or no slope, a horizontal line that indicates a stable voltage, direct voltage. Could be 5 volts, could be 9 volts, could be 12 volts, 24 volts, etc., etc. When it goes to a half bridge or full bridge rectifier, there are clever techniques and topologies using diodes in which current flows in only one direction, capacitors which acts as a spring, and resistors which resist the flow of current. Can be arranged in clever topologies to have the voltage outputted as a stable waveform, a stable direct current. And when you go to internally inside of a phone or a laptop, an LDO is a low dropout regulator. What they do is there's an input side and an output side. Just as many devices have inputs and outputs, either a power input, a data input, a power output, a data output, then what happens is there are input capacitors on both sides that mitigate the fluctuation of voltage. And stabilize. Think of it as a compression spring or suspension spring in a car or a bicycle. And in physics terms, when going on the topic of loss of energy, much of that energy is lost through heat or friction. In mechanics, there's energy that is lost through friction, and in the electricity, there's energy that is lost through heat dissipation, either through a voltage divider or through a linear dropout regulator, which needs to be attached to a heatsink to cool off the thermal dissipation. So that's AC and DC waveforms and voltages, as well as the basics of LDOs. An example of an LDO would be an LM317 or an LM337 or an LM7805, which takes the input voltage of an unregulated voltage, such as anything that is above 15 to 18 volts, 20 volts, drops it down to a regulated voltage such as 12 volts, 9 volts, 5 volts, etc., as low as 3.3 and 1.8 volts, which are standardized through the IEEE Institute of Electrical and Electronics Engineers. This is a quick summary on the topic of AC, DC, voltage, and LDOs. So thanks for tuning in, and I'll catch you next time.